Hyperbolas. Right, hyperbolas, we know exactly how a hyperbola looks like, but a hyperbola is a locus of a point moved so that the difference, that's why we have the minus, between the distances from the two fixed points is a constant, k being my constant. Standard form of the Contagion is x squared over a squared minus y squared over b squared equals 1. Or if it's translated, we get that, centre, h, and k. Asymptotes. Easiest way to work asymptotes is to use that. That's applying the transformation from x goes to h and y goes to k. We obtain these results, and therefore the asymptotes we can use that rule there. Example 13. For each of the following equations, sketch the graph of the corresponding hyperbola, give the coordinates of the center, axis, intercepts, and the equations of the asymptote. So part A over here, I'm just going to rearrange it or rewrite it in the form of 2 squared equals 1, so that's easy. So the asymptotes are y equals plus or minus b over ax, which means in this case I have y equals plus or minus, b is 2, there it is there, a is 3, so there's my b, there's my a, so I end up getting 2 over 3x. X-intercept, y equal to 0, solve for y equal to 0, I get x squared over 9 equals 1, x squared equals 9, so x equals plus or minus 3. So this one here, I'll try and graph this one. A bit hard to do it like this, but anyway, I'll try and graph it. Y, x. This y equals positive 2/3 x, that line there, negative 2/3 x. So when x is 1, I get 2/3. When x and negative 2/3. So I've got a point there going through the origin, there going through the origin. So there's the y equals 2/3 x asymptote, and y equals negative 2/3 x asymptote. I also know that this one here goes at 3 and negative 3 this graph, so it comes like that and like that. Okay, probably the best I'm going to do is on these, trying to graph it freehand like this. Part B, y equals x squared divided by 9 minus, sorry, y squared divided by 9 minus x squared over 4 equal to 1. So again, I'll write it y squared over 3 squared equals, sorry, minus x squared over 2 squared equals 1. Working out the asymptotes using the rule y equals plus and minus b over ax, which means I get plus and minus 3 over 2x. X-intercept, if we put y equal to 0, we're going to get negative x squared over 4 equals 1, so not possible, don't even bother because it's a negative. So the y-intercept, putting x equal to 0, and it gives me y squared over 9 equals 1, y squared equals 9, so y equals plus and minus 3. So trying to graph this one, not much room, but anyway, x, y, do this line over here, I've got an intercept asymptote, this time it's at 3 on 2, sorry, no, 3 and negative 3, so I get that and that, and I should have realized that from here because the x is negative. Alright, part C, x minus 1 squared, this has been translated 1 unit right, so really I've gone x to y has gone to x plus 1, oops, that's a comma, and y minus 2. Okay, so that's what's happened there. So the asymptotes, I'll have to use y minus k equals plus and minus b over a x minus h. In this case, I get y plus 2 equals plus or minus 1 divided by 1 is 1, x minus 1. So I get y equals x minus 1, take away the 2, so y equals x minus 3, and I get y equals negative x plus 1, take away 2, which means I get y equals negative x minus 1. The x intercept, y equal to 0, and I get x minus 1 squared minus 4 equals 1, x minus 1 squared equals 5, so x will equal 1 plus or minus the square root of 5, and the y-intercept x equals 0, and I get 1 minus y plus 2 squared equals 1. I get y plus 2 all squared equals 0, but square root is still that, so y equals negative 2. I'm not going to be bothered graphing that one. You guys can graph it. D. And this one here, again, I'll write it in the form y minus 1 squared over 2 squared minus x plus 2 squared over 3 squared equal to 1. So the asymptote y minus k equals plus or minus b over a x minus h. This one has a centre of negative 2 and 1. So I get y plus 2 equals plus or minus 3 on 2, x minus 1. So I get y equals negative 2 plus or minus 3 on 2, x minus 1 in brackets. I get y equals negative 2 minus 3 on 2, x plus 3 on 2, which makes it y equals negative a half minus 3 on 2, x. And I get y equals negative 2 plus 3 on 2, x minus 1. So I get y equals negative 3 plus 3 on 2, x. So there's my asymptotes there. Example 14. Using the locus definition, consider the points A and B, find the equation of the locus of the points that satisfy that rule there. Okay, so we got the AP minus BP, we've got the distance formula, so I'm doing distance between this and P. P is going to be x comma y, so I get x plus 2 squared, y minus 0 squared is just going to be y squared, minus x minus 2 squared, and y minus 0 squared is just going to be that, equals 3. Okay, so I'm going to move 1 across and get the square root of x plus 2 squared plus y squared equals 3 plus square root x minus 2 squared plus y squared. Square them, which gives me, and I'm going to expand this one at the same time. Hopefully I'll get it right. I get x squared plus 2x plus 2x is plus 4x. 2 times 2 is 4 plus y squared, or equal 3 squared is 9 plus 3 is plus 6 of this lot, x minus 2 squared plus y squared, and this with plus x minus 2 squared plus y squared there. Okay, so I can, that's going to go, should expand, and I'll leave that as it is at the moment. This is just going to be x squared plus 4x plus 4 equals 9 plus 6 square root x minus 2 squared plus y squared plus x squared minus 4x plus 4. That will cancel, plus 4 will cancel. Bring the negative 4x on the other side, it becomes 8x. I'll bring the 9 across, it becomes that. X minus 2 squared plus y squared, all under the square root. Okay, square all this. And I get 64x minus 1, 44x plus 81 equals 36x minus 2 all squared plus y squared. Okay, which becomes 64x minus 144x plus 81 equals 36x squared minus 144x plus 144 plus the 36y squared. And therefore I get 28. I'm going to continue it over here. 28x squared minus 36y squared equals 63. Divide everything by 63. And I get 4x squared over 9 minus 4y squared over 7 equals to 1. 15. Find the equation of the locus of the points P, X, Y. It satisfies the property that the distance from P to the point that is twice the distance for that. In other words, this. So FP equals 2 MP. Okay, so the distance from F to P is X minus 1 squared plus Y squared equals twice. M to P is X plus 2 all squared. Okay, I'm just going to square them. And I get, and I'm going to expand at the same time, x squared minus 2x plus 1 plus y squared will equal 4 x squared plus 4x plus 4. So x squared minus 2x plus 1 plus y squared will equal 4x squared plus 16x plus 16. And therefore I'll get 3x squared plus 18x plus 15 minus the y squared equals 0. So 3x squared plus 6x minus y squared plus 15 equals 0. And when I factorize this, I'll get 3x plus, this will be 9. I'll just go like this, 9 in here. Alright, so plus 9 in there, minus 9 there. I get x plus 3 all squared minus y squared equals 12. And divide everything by 12. I end up getting x plus 3 squared divided by 4 minus y squared divided by 12 equals 1.